Mr. Python, how you doing? 81G? You set an alarm for this? The time changed. Yeah, I was gonna do this. I was gonna do a course earlier today, but then I thought better of it. I was actually kind of busy. I had to go mow my yard, and so I figured I would just do some like generic Python office hours. And I can't believe you had an alarm set for it. If I knew someone had an alarm set for it, I never would have canceled. Never. My yard would still be long. It was getting bad though. My dogs get iffy and they don't want to go out when the yard's too long. That's awesome. I was actually thinking about doing a little RL bot Python. I had a little project where it just like resets the shot. It's really basic. But man, did y'all come here for some basic Python? Because I can start from the beginning. We could do a little basic Python. Or, do you want to see some Rocket League stuff, or do you want to see or with Python, or do you want to see a little basic Python? You have some knowledge. Okay, okay, yeah. So the thing I'm going to look at is RL bot. This is what everyone does the crazy Rocket League bots in. Like they just do absolutely insane things with them. I'm not going to work on a bot. What I'm trying to do here is like build a shot pack, because what you could do, you could build a shot pack and then you could put a goalie in there. So like you could build shot packs that have goalies, or you could build shot packs that have opponents and like try the same shot over and over again, which would actually be kind of sick. I haven't really heard of anyone doing it, which is kind of surprising. And you could actually do like make defender packs, so you could like set up bots to take shots on your net and then you have to defend against it. It would actually be kind of insane. Like, it is not there. The only thing I have right now is I set up a shot. Yeah, it's in Python. I set up a shot that lets me pop aerial just so I can like practice flip resets. But I need to get to the code. So yeah, if you just Google RL bot, like they have a great community, and their website's it's pretty good. The thing about programming a Rocket League bot is the coordinate system and the transforms, and you deal with angular rotations and the physics and stuff. Like the bot programming itself is actually really hard, but it's not too bad just to kind of get the environment going. But yeah, all you have to do is download and install RL bot, and then I need to find my way to the code, and then I'll fire up the bot and we'll see what we can do here. So I named it Rocket Python. It's the code's gonna be on my GitHub. Let me make sure it's still a public repo. I think so. It's not good. It's nothing fancy. But the code is out there. Yeah, so that GC bot is in here. I could absolutely have it destroy me. I think the good one is... It's in here somewhere. Necto? Yeah, oh, so Nexto, Toxic, and Nexto. I'm not sure what the Toxic one does. Maybe it just, like, has no mercy. I don't think it demos, but they do have, like, demo bots in here and stuff. But yeah, this Nexto will absolutely destroy me. And I'm probably, like, on a good day, I used to be, like, D3, almost Champ 1 in ones. So this is that rock solid Python you're looking for? Yeah, yeah. It's the Rocket Python. It's not... It just keeps getting worse, man. I cannot win. Like, I need to make a rule that there's no making the obvious joke for any of my courses or any of the file names or any of that stuff. All right, let me minimize this and see if I can get a new window here. And then I actually want to open that folder up. There's no telling what's in here. Danger zone. All right, there we go. Nothing like searching your file directory live on the internet. Nothing wrong with that. Some people just don't get sarcasm. I know, man. You should have seen Reddit. The post I put on Reddit earlier, I got so many downvotes, it wasn't even funny. Like, I made a joke in the Learn Python section, and I just got destroyed. Like, absolutely destroyed. It balanced out. I ended up getting enough karma back from it. But, yeah, someone asked why everyone... Yeah, someone asked why do people use Macs for Python development, and I put programmers are elitists and so are Mac users, so it's a match made in heaven. It used to be -7, but some people hooked me up and gave it back. But I've never seen like a poor reception of a joke. So like if you go on the Python subreddits, yeah, don't. Oh, that repo might be public or private. Let me go set it to public. I think I have like Rocket League bipolar. I will quit it and reinstall it like nobody's business. It's like not even funny. It's like either I hate the game or I love the game. It just goes back and forth. Change to public. I want to make it public. I have read and understand these. Make public. Okay, I think we're good now. Yeah, so the code is like super basic. Put that S. Oh yeah, yeah. I gotta tell people it's a joke. I think that's what happened. Like in the thread below it, I kind of was talking to some people. Like one person got it and said they upvote it, and then I told them I'd upvote him because he actually got the joke. And maybe a couple of people like recovered it for me. But man, I thought all of Reddit was for jokes and sarcasm. Apparently not the Learn Python section, I guess. Even though people are like lighting, like if you go in there and ask a dumb question, people will like light you up. All right, we got the code. Where's it at? Okay, so this is just like shots. So I started breaking it apart, and all I did was, where are we at? I defined this shot. So I made like a shot class where I can put the ball somewhere. So we have this ball state, and then we define like the location and the velocity of the ball. Kind of like if you were just if you were in Rocket League trying to design your own shot. You kind of have these like, this is like intermediate Python. So once you get the object-oriented stuff, this is like object-oriented programming. So yeah, a shot is just going to be a class. So that way I can go and make different shots and build new and better shots. But I should probably run it just to see if it works. And then I'll let that bot dunk on me for about 30 seconds. But then I'm not playing a match versus that bot because it's a bad time. But yeah, let me do this, and I'll adjust my, I gotta adjust my game screen and get that over here. But this is like the bot output window, so you can actually see the chat coming out while the bot's running. I wonder how loud that is. Might have my system volume a little loud, but let's see. I just gotta shrink my video down to something reasonable here. And apply. There we go. Maybe I can do a little bigger. A little bit bigger. Yeah, okay. Now we can see a little bit more. Okay, so the bot is actually just going to sit over there. It doesn't do anything. So the bot is just kind of there for the shot pack. You can make scripts in here. But I managed to map the shot reset button. This is like, all I've done is make a terrible shot pack at this point. But yeah, so I can reset the shot. And what I was going for is like, if I hold down the gas button, I get a pop aerial. So like if I just hold the gas button the whole time, and then I get a pop aerial, so I could like practice my flip resets. And you can see I got the flip, but I didn't hit it. But the other thing that it does is it randomly spawns the ball around the court or around the field in different locations. So every time I reset the shot, I'll be... That is not working. It's like barely randomizing it. Okay, there's a different one. It like randomly put me in the same spot like 5 times. But there's other things you can do where I had like an older version of this that I don't have the code for, but it would like detect the flip. So if you wanted to design a shot that required you to get a flip reset, you can like put a flip indicator on the screen, and then whenever you get the wheels on the ball, it'll actually like indicate that yeah, you got the flip reset, and it's actually kind of cool. But usually what I do is I just kind of like I'll just play it, and if I see something I need to fix, then I'll go in and fix it. One thing right now that's kind of annoying is when I do the shot reset button. So like if I just make it, and now I tap the shot reset button, it teleports me back to the beginning of the shot. Like you can see I keep teleporting my car, but it doesn't reset the shot. It just, all it does is mess up the video. And then I can skip it, and from there I have to reset the shot. It like doesn't automatically redo it. So like, it's all in the logic of the Python programming. So there's like a lot of stupid little things to do. But I'm not too worried about those. Let me go stop this, and I'll show you the bot that like is a GC, because it will absolutely clown on me. So yeah, if you download RL bot, you can just play verse it, and it's this was all trained with reinforcement learning. So I mean, it's got like hundreds of thousands of hours of compute time training the thing, and it's much better than me. I know Magic Burrito, he can beat this, but yeah, me not so much. It took its sweet time. I think it was like loading up there or something. But as long as it's running right, it's absolutely gonna clown me. Yeah, like it just puts those in. Not even fair. He just flicked it into the backboard. Like, look at this flick. I guess I'm supposed to read that on the backboard. I have no idea. Yeah, it just dusted me to the kickoff. I'm surprised they didn't just put that in, honestly. Yeah, it's really good at just catching the ball and putting it in. Like, it will control things that you would not expect someone to control. So it's absolutely... I can't just front flip to the ball. It just, like, absolutely does me. I wonder if... I mean, so it does, like, perfect speed flips is what that is. Yeah, perfect speed flips, perfect catches. So I can get a block on that kickoff, so I don't just get dusted. But yeah, like I know it's taking 3. So, like it'll just like, I'm surprised it didn't put that in net. That's like one of the only times it hasn't been in my net. I almost peaked. I'm not even gonna stay around. Yeah, we've had enough. Yeah, I would say I'm gonna stay around until I score a goal on it. But, like, it just doesn't even make sense. Like, it doesn't even add up. Get me out of here. Let's stop this thing. It's so bad. How does it know the controls and what to do? So, it's called states. So, bots have, like, states, and then they have these input states, like the game state. So, all the game state is put into this big machine learning model, and then the outputs on the other end of that machine learning model are just the control states. So it figures out like when I'm in this situation and I push these buttons, I get a reward. And the reward will be like scoring a goal, saving the ball. Like the biggest thing for them is probably their reward function. I have no idea. Like it's really hard to pick a nice good reward function. Like if you want to train a bot to dribble the ball, you have to give it some sort of reward function where it gets points or it gets rewarded for having the ball on top of its car. And it's really hard to do because it has to explore everywhere. Like, it's kind of like, it'd almost be like, I don't know. I mean, they did it with, like, apes or monkeys, like, playing video games. They gave them grape juice. And, like monkeys learned how to play video games, basically, because they would get grape juice as a reward when they did the right thing on the video game. And, I mean, it's not different. It's not a lot different than us playing video games either, though, right? So, yeah, it's so good that it's insane. Like I thought, like when I played Necto, it was really good. I was like, oh, this is serious. And then so what's weird is all the machine. So the reinforcement learning, the code for it's not that I'm gonna say it's not that complicated. It is, but it's about the reward functions and the training time, and then they probably have to like curate the training scenario. So like they probably run it through shop packs and all sorts of crazy, like they curate the situations that it trains on. They don't just let it openly play anymore because it probably doesn't learn enough from just randomly getting around the field. But what's really complicated is they have the old school bots that are hard coded. Like they have some manually coded bots in here, and I think the good example of the randomly coded bot, or the manually, excuse me, not random, like the manually coded bot is Bumblebee. And if you're around like Champ, like 1v3ing the Bumblebee is actually pretty legit. So these things, like the thing about the machine learning bots is it's done with reinforcement learning. So they have to pick the reward function and then it just does its thing. But these Bumblebee bots, and you can see I have debug mode on. But these things are like manually programmed, and they like have perfect rotation. So like one of them is always going back, one of them is watching the net, and like one of them is attacking. And they can aerial and stuff like that. Like they'll go up for the ball. Like they're really good. So these are probably my favorite like hard coded bots. But there's a group. They actually had to separate the tournaments. So the machine learning bots got so good that they have their own class now, and they don't even. They don't compete versus the hard-coded bots anymore. So, yeah, they had to separate them. Like, these have, like, those kickoffs are, like, manually in there. Like, I could go in and steal the code for the, whatever it is that they do on the kickoff, and you can, like, train against their kickoffs and things like that. So, yeah, these are, like, really cool bots. But you can 1v3 these things with just, like, some probably high diamond skill or something like that. It's a really fun match to play. Yeah, it's super legit. I can go look at. This was actually I was doing an elite code like challenge problem with this like data engineering group I'm in. But I gotta see if I have some like to do stuff on this bot, and maybe go look at that a little bit. So this is the general shot, and it's really important to have the field up, actually. Yeah, so like the RL bot site, super important. You can't really do anything in here without it. Let's see. But yeah, if you just go to like it's rlbot.org, I think, is where they start out. And then useful values. This is like, so you can just like see the field here is what I'm looking for. Yeah. So like this, they have like these XY coordinates. So like X is to the left side of the field and Y is towards the enemy goal. So I set it up to where I'm shooting on the orange goal, so I get to look at the same thing. So I set the ball to be in the middle and then back 1800. So this whole depth here is like 5100. So like this back line here is about 5000. So I put the ball back here, and then it's 1,000 units up into the air. And this is just Unreal units is what it is. So you can see like the ball is back this far, and that's the Y position, and then the Z position is how far up in the air it is. That's 1,000, and then I give it an initial velocity of negative 1,000 in the Y direction, so the ball is like flung towards my car, and I put my car back here. So yeah, you can see like when I do my shot pack, you can see that the ball is just up in the air, and then I use this velocity to get it to my car, and I kind of timed it out to where this is the location I have for my car, and I actually need to be just a little bit farther away because I get there like a touch too soon. And I timed it out to where if I just drive my car at full blast, I do like a perfect pop aerial. And then in order to not just have the same shot position over and over and over again, I put this transform location, And what it does is it randomly creates a car movement. So my car is just chilling here in the backcourt waiting for the shot to happen. And then I randomly reposition it in the backfield. And then I rotate the ball. I move the ball like with respect to my car so that the shot is still straight on net. Let's see, yeah. So I grab the car location. Like all the values for this are buried like in their documentation here. So like this has the game tick pack value. So like this game tick packet has all of the field information. It has the car position. It has like everything you need. And then the controllers are how you actually set the controls. So like I could send input to the opponent bot, but I don't do that. I'm not really interested in programming the bot. I want to make like a training pack that's like a little bit more progressive and kind of like gives me different shots and things like that. And then keep score. Like you can, like I'd like to add a database, like a database in the back end where when I make a shot, you know, I log that I made a shot. If I miss a shot, log that I miss a shot and that sort of thing. But yeah, I had to do a little bit of nasty math on it. So I had to, when I rotate the ball, or when I move the ball to where it's still perfectly in line with the net, but it also keeps that same distance away from my car to give me the perfect pop area where I go. There's definitely like some trig in here. So it got a little bit nasty, but the physics between the rotations and the angles of the car and when they're in motion and you're boosting them, I mean, it is literally rocket physics. I mean, that's all there is to it. So it gets really heavy really fast. But I'll spin my bot up again so you can see like the ball is moving and the car's moving, but the shot is always perfectly on net because I didn't add any sort of variance to take me off target, like off net. Oh, you're getting in geometry class flashbacks? Yeah, that's just the beginning. Like, have you done the trig yet, Mr. Python? But yeah, trig is like often thought of as people say it's like the most useless math class, and it is if you don't use it. But if you do engineering in school, it's like the most useful math class. Yeah, so you can see like the shot is moving, but the ball is always straight at the net. Like no matter where I spawn, I'm always pointed straight at the net, and I'll do a pop aerial if I just do full gas. So it's like a really cheesy way for me to just like get a perfect pop aerial and then try to work on how fast I can get up to the ball and then maybe do like a backboard reset or do a double tap or something like that. So the only way I can mess up the pop aerial is if I'm not like holding down the gas the whole time or if I boost or something like that. Yeah. You did some trig in geometry. Yeah, it gets like just the basics. So just like sine, cosine, and tangent, like it just unlocks everything when it comes to stuff like this. Yeah, when you're looking at the field, and it actually was pretty hard for me. I embarrassingly did it on live stream. But these coordinate systems, see how the x-axis points to the left and the y-axis points up? That's actually different than the coordinate system usually is. Like it was a bad time. Luckily, no one was watching. You know what I'm saying? So, but yeah, it was. I got it worked out on stream, and then I went and I cleaned it up a little bit afterwards. But I might have a little to-do thing. Where does it get greater going left? Yeah, it's so the reason is and the z-axis comes out of the screen. And the reason for that is some of the photo editing software and like graphic design software, it has what's called a left-handed coordinate system. So everyone that does physics and engineering has a right-handed coordinate system. And the x-axis would always be pointed to the right, and the z-axis would be pointed up out of the screen. But Unreal Engine, maybe Blender, and like Cinema 4D, like a bunch of those graphic design softwares, they have a left-handed coordinate system. So it found its way into some of the gaming software for some reason. And it doesn't mess things up that bad, but I have a hard time wrapping my brain around it. Luckily, a lot of the math works out. So when you do some more advanced operations on it, it usually works out. Like the negative, like you have to carry around these negative signs places where you wouldn't expect to have them, but they usually tend to cancel each other out. So like all the same formulas that you would know and love from physics like tend to work their way out if for people that do this sort of thing. But yeah, I have some sort of to-do list for this bad boy. Yeah, you've never. Yeah, if you do, I'm not sure about Blender actually. So a lot of people do Blender, but I know I did some Cinema 4D, and I think I think I chose it because it was a right-handed system, but I don't remember. Mm, I don't actually do any Blender. How do I move this bad boy? I like this one to move. So this axis, this is the y-axis. This is the x-axis. Yeah, so x is positive this direction, and y is positive this direction, and z should be positive going this way. Yeah, so it looks like this has a right-handed coordinate system because x goes this way, it's getting positive. Y goes this way, it's getting positive, and then z, the number is increasing as you go up. So this has a right-handed coordinate system. So it gets weird because when you build a model in this, all your axes don't line up with Unreal Engine. Yeah, so it looks like Blender is normal. So when you build your assets in Blender for Unreal game development, you have to, a lot of times, I think you have to export it for Unreal. Like it does the transform for you, but you have to transform it to those coordinates. Otherwise, when you load it in the system, it's like really like I think it comes in backwards or something. I don't, like it has little problems. Like it's all worked out because people do it. Like Blender is super popular and Unreal is super popular, but their coordinate systems just like they don't freaking match up. But I don't do any Blender. I put that on here out of ambition, but I'm never going to learn any Blender. I can actually just close this. That's on here because I wish I knew it. Just get it burrito into coding. If you can get Burrito on here, I'll get him through his Hello World. We'll go do some like really basic programming stuff. I'll kick it off. Because so this bot stuff is actually really complicated, and when I work through it, it's not like I'm working through it for myself. It's really hard to follow. Like it's actually kind of stupid to watch. But so I opened up this is for like just anyone taking like a beginner or intro to Python course can just come in here and like ask questions, and I'll try to answer them. Like whether I'm like I could like help with I won't do homework or whatever, but I could like help people solve problems. So yeah, I would be game. It would be lost. Nah, you don't have to be. So getting into Python is so easy because you don't even have to do anything. Let me just go to a collab and make sure that it's like it's good to share. Yeah. All you got to do is go to like collab. This is zoomed in to some level that I cannot even believe. I don't know why it was like 250% zoomed in. But yeah, if Burrito's here, we just get him to open collab and then go new notebook. Oh, this is blinding me. I'm a dark mode kind of guy. Yeah. And then this is it. Like, you got your Python right here. You can just run it in collab. It's like so easy. Yeah. Yeah, they didn't teach us anything useful. We had to go out and find the good stuff on our own. Yeah, that's unfortunate. It's hard to have a good class, man. Used Code HS. What is Code HS? Oh, that's rough, man. Yeah, when I took my first programming class, they just said like use whatever text editor you can use, and then you submit your code, and if it works, it works. And I remember I was developing like I was doing C++ because I learned C++ was like my first thing. It's not like a webcam on, crazy. But yeah, so I learned C++, and I wrote a program on Windows Visual Studio, and it like there's some like stuff in there that's different, and I submitted it, and my teacher, he took all his code and compiled it, and that stuff ran on Linux, and yeah, it was a nightmare. Like it did not work out. You got points out for using exe to have variables named in order without having to do it manually. And like 20 points off. What's exe? Let's see. Is that in Python? Execute the given source code. Yeah, you probably should get points off for this, though. I'm not gonna lie. That's funny. So this is the reason I don't know what this is because this is like execute the given source in the context of globals and locals. The source may be a string representing one or more Python statements. Yeah, so this is it's not helpful. This is dangerous, man. So like what like if I had a like if you had a server running and you accepted code and then you ran it with this, or if you were like just running arbitrary files, so it's like this is one of those things that's a vulnerability is what it is. So even there's another one, there's like a data format called pickle that will actually allow you to embed Python objects, and when Python loads Python objects, it can execute arbitrary code. And it's just like this huge security vulnerability. So like, yeah, you're always trying to stay clear. Like anything that takes arbitrary code and executes it for you is a no-no. I don't know if that's why he took points off on it. So he might have just taken points off because it wasn't the same thing that you were doing in class. But I would point out that this thing is probably a big security vulnerability. Used it for making multiple variables that had an order in. Hold on, I've never used this. So what you're saying is like name is equal to like variable for let's just grab like 5 of these things. This is this is hilarious. Exec. Do like a F string on it, variable, and you put the little number at the end. We can put an underscore there, and then that'll convert that thing to a string. So we can also print this out just so we can see it. Oops, no. So I'm going to print the code. And I'm going to say that this is the code. So variable underscore the number is equal to the number. This is cracking me up. I'm glad you brought this up. This is so that prints it. So all that code ran in Python now. And now I can print. Oh my god. Yeah. Oh, I get what you're saying. No, this is super convenient. Like, I get why you want to do this. Like, I completely understand why you want to do this. It's also, like, so what the problem is like, if you do something like this, like, whatever, f.read lines. Something like that. I don't know what actually. One of these things will read the whole file. So like if I load a whole code file as a string and then I tell it to execute it, or if you're accepting strings from somewhere else and just executing arbitrary code, this is like a huge no-no. That's why like this is a massive security concern because this would just execute any arbitrary code that happens to be in that file. And this is assuming that it's like open to users and stuff like that. Yeah, like when you're learning to code, this stuff is cool. And it probably has some good use cases, but I would not run this like on my server or something like that. You know, like that's a no-go. To be fair, though, those projects you did weren't anything security related. Yeah, exactly. So in the education environment, you get to do all sorts of silly stuff. Yeah, this is cool. I actually like this. See, I'm supposed to be teaching Python, but I'm like learning Python because you're bringing me this cool stuff. Made a board game Mastermind in Python for a project. Mastermind. Is that the code breaking game where you got like the 4 pegs? Also, how bad is the delay on this? I think I forgot to set the stream to a... Oh, no. That's on. It says it's on low latency. Okay, 2480 and TK enter or tkinter. Yeah, that's just like the... That used to be like the go-to GUI programming thing. Okay, yeah, I put it on. It looks like I have it on low latency. So the normal YouTube latency is terrible. And if I had forgot to set it, like it would be a bad time. Code HS. Looking at Mr. Python using code HS. So let's see. So 81G made 2048. That game's legit. I made for like board games, I made Connect 4 and it ended up being like Connect whatever. So you could change it into like Connect 10 and you could set the board size and all sorts of stuff. I wish I still had the code for that. I had it on like an old YouTube video that was part of a different channel. But yeah, it was super cool. Yeah, Connect 4 is like really it's pretty straightforward. I used a Pygame for the GUI, but I also made like a command line version of it. Had to present to the class. Speaking of presenting, yeah, I got a project to work on for my data engineering course, and we're presenting in like 2 weeks. It's going to be interesting. I got a lot of work to do, and meeting with my team tomorrow to try to make it happen. Some of them might be in here. I don't know. I share this video in my Discord server with them. Nah, I don't know if I'm carrying the team. It's just hard. I'm not doing enough work to say I'm carrying the team. I'm probably like I'm probably like the best at Python in there, but then we got someone who's pretty good at SQL. We got a dude who's like pretty good at management and just like being a good human being. You know, like programmers struggle in the social area. And I got a dude in there who plays Rocket League. He's like the same rank as me, so he's cool. But yeah, it's going all right. But everyone's on different schedules and everyone's busy. And I was doing some work on it earlier this week. I got I'm working on GCP, Google Cloud. I uploaded the stuff to, it's called Cloud Composer. Let me look up a Apache. Let me look it up. It's Apache Airflow. Yeah. So it's this is hideous. Every programming site should be dark mode just by default. But yeah, so you have like these blocks of Python code. Like every one of these little blocks represents some Python code, and then you just connect them together and it can only move forward. So instead of having to organize your code with a whole bunch of loops and if statements and crazy stuff like that, you actually you write a bunch of blocks of code and then you connect them to each other, like literally with little arrow symbols in your code, and then it just runs. So like this, it's going to bring in some data, you're going to use some Python code, or you're going to export it somewhere else to do some analysis on it. You're going to like check the data, you're going to save it off somewhere, and then you're going to do like an alternate. So this is like parallel processing. So it's like, oh, you do something here to check the integrity, and it's like, okay, well, I can go this path and I can go this path and do those two things in parallel. And they actually run on, like, these can each run on a different computer, so you can do big data stuff with it. So like you could have like terabytes of data that you feed into this ingest, and it's just like it's sending this out to different machines to do it all like it's orchestrating the workflow. Yeah, it's super cool stuff. I wish I was good at it. See, Mr. Python, one of the lower level games was a maze. People would just add frames for walls, but you could move through the walls because people didn't want to have to deal with that. Yeah, so what they were skipping is the collisions. Yeah, so collision detection is a nightmare. And if I was gonna program collision detection, I would just look up the algorithm for it, because usually, I saw it I did it on the autopilot system I worked on. So they had a collision detection going, like where you were flying the plane, you could set a GPS boundary around the plane, because if it was an unmanned plane, so it was like a drone or whatever, or like an RC plane that was just automatically piloted. But if it went outside the bounds of where you wanted it to fly, it was supposed to shut off. So you had to like draw this box around it and then hope you never cross that line. And but yeah, it was collision detection basically inside of there. It was like they had this special code. They had code in there. Like I went and I looked it up and all that stuff. But it was like, yeah, if the plane was outside of that box, it was supposed to shut off. But yeah, I would look up the functions for collision detection like immediately. You can just compare like X and Y values and stuff like that. But it gets really out of hand. So if your shape has like 1,000 polygons and you're trying to detect if it's on the other side of a wall that is also made of a bunch of polygons, the math on that, like, it's a nightmare, right? Is there some website that was like a mass Python function list that has all the functions? Yeah, yeah. It's called the documentation. It's great. So that's why I got docs right here. But I don't even have the Python documentation. Yeah, right here. So like this is where I would actually have people start. Like, yeah, I don't even Stack Overflow anymore. I use ChatGPT first. But like Python, if you're just kind of like things like, and you're just looking to see kind of what's out there, this documentation is what's built into Python, and this is awesome. So like the Python documentation, it's pretty good, and you just kind of come in here to look around. But the other thing is PyPI. So all of those libraries that you use, like that bot that I was working on, is the RL bot program. And it's not actually distributed by PyPI, but everything is in here. So this is the framework for writing custom Rocket League bots. And if you go here, they tell you to go to the website because this is not open source. So all of the code that interfaces with Rocket League, they're not allowed to release it to the public. So they couldn't do the full source code. The last time I checked, they didn't have the full source code up here. They only give you part of the code. The rest of it, they need to maintain a good relationship with Psionics. But something that like a lot of people use is like TensorFlow, something like that. So this is like the machine learning software. You just come here, it tells you how to download it, it tells you how to use it a little bit. Yeah, so many websites that listed functions for certain modules or parameters and methods would miss stuff. Yeah, it's a nightmare, man. It really is. The other thing that's cool is just having a good system. Oh yeah, 81G. Like the reason they never told you that is like half the teachers barely know what they're doing. Like it's just true. I mean, like Python, like so my kid just took a intro to Python programming class and it was great. Like they had really good stuff, but they still did all of these things that were like, it was just bad and ugly Python code. And there's this course called Python for Everybody. Yeah, so this guy, he runs a really good Python course. I took his, so this guy wrote this great Python course, like 4.8 stars, like everyone, like he's got like really good reviews and stuff. Like people just like, it's a great Python course. But I took his SQL course and he gives you like sample Python code that he wrote in there. And it's like really janky. It's like, it's actually kind of bad code. And I'm like, oh man, like this dude teaches Python. Like, I hope his Python course doesn't do code like the way he does it in SQL. Like, I had like some mixed feelings about it. Like, it was fine. It did what it was supposed to do. But like Python is all about like writing. It's what's called Pythonic code. It's supposed to be like elegant. It's supposed to like do certain things certain ways. Yeah. The other thing is there's just so much to learn. So sometimes they don't tell you these things. Oh, Mr. Python lucked out. He had a good teacher. But yeah, sometimes they don't tell you these things because there's just so much to learn. Yeah. Yeah, exactly. Like there's no limits on it. So like there's just all these weird things. Like if you were going to work with a data file, like you're supposed to do like with open file name as f, and then you use it, and then then you're done and you get out of here and it closes the file automatically. But like this is what's called this is like a context manager, and a lot of people just won't teach this, even though it's like it's the preferred way to do it. Like you should never, like what a lot of people will do is they'll say like f equals open file name, and then down here somewhere they have to do f.close and call it, and it's just like this is not, it's just not how it's done in Python. Everything in Python is done with this context manager, because you open the file, you do what you need to do, and then you just go back your indent and it automatically closes it. But like people just teach like this janky stuff for no reason, like, and I'm not even sure what's going on. Like it's one of those things, like I don't bother to teach it when I teach it, because it's just like hey, you're gonna see this somewhere. It's the same thing, but this is the way to do it. Like you're supposed to use context manager, because then you never forget to close your file. Like you can't possibly forget to close your file. Mr. Python, You didn't learn about classes. So they're confusing because you see them everywhere. We can go over a little class. We can build a class right now, I guess. We could build a car class or a vehicle class. Let's start with a vehicle, right? I'm gonna type some stuff out here, and then we'll go from there, right? Yeah. So just to build an object in Python, like the easiest way to think of object-oriented program is like objects are just things, right? Like with the self and stuff. Yeah, it's confusing, right? So the double underscore methods usually they're referred to as dunder methods. Hold on. I don't know why my camera's light is on. I know I'm not like broadcasting my camera, but it's like creeping me out that my camera's on. I just had to like unplug that. But sorry, it's like distracting. Yeah, so these are usually dunder methods, or sometimes they'll be called magic methods. Yeah, dunder, because it's always like underscore underscore or double underscore. So yeah, people just say dunder. Hey Nuggies, you saw my Haskell tutorials. They were great. Glad to have a chance to. Oh, thank you so much. So, Franz, my Haskell tutorials are still on the internet. They're just not publicly visible right now. Like, I could actually turn them back on. It's not really a big deal. I made them under JBarcode. So, yeah, I appreciate the thanks, man. Yeah, those were really fun. I wish I was still doing Haskell. I'm not in that ecosystem right now. But yeah, these Python dunder methods, they're special to the object, and they let you do special things automatically. So all it's doing is saving you some code and doing things automatically. So if we're going to define a vehicle, like what are some things that a vehicle would have? And self is going to refer to a instance of a vehicle, or it's kind of like a copy of a vehicle. Whenever I create a vehicle later on, self is how it refers to itself. In most programming languages, this would be called this. Self would be called this. And a lot of times they don't even spell it out. It would just look like it wouldn't even be there. It's actually, most languages, the reference to an object within itself is implied. But Python is special. It's always the first variable inside of a class instant or a class method. So this thing is a class method. And this thing is a magic method, because it's got the dunder, right? Yeah, so it's a dunder method, right? So these magic methods, they do things kind of without going out of your way to ask them. So what are some things that a vehicle would have? What do we want to give this? Like, do we want to give it some doors? Like most vehicles have doors, right? And if you're doing things right, your car probably has 2 doors, but I haven't had a 2-door car in too long. Oh no, my YouTube packet loss. It's suffering. Hopefully it's still going good. It's got an engine. We're doing like, what do we want the engine to be? Like do we want it to be a string? Like an inline 6 or something? So this could be a string. And then wheels. All right, so we can go back and we're gonna change some of this stuff. Windshield. Maybe like a car has a windshield, but like a motorcycle. Well, I guess a motorcycle doesn't have doors, right? And it's a vehicle. So you know what? Maybe a vehicle doesn't necessarily have doors. Let's just go with an engine and wheels. How about that? Let's stick with engine and wheels. Okay, and if we want to use this thing, we're going to go down here, and we're going to make one. So all we have to do is we call this class up with some open and close parentheses, and now we've created our very own vehicle, right? And we're going to try to print it out, and we'll see what happens. And it's probably not going to go very well. But I'm going to run this, and I think I can zoom in just a little bit more. Okay, so down here, we printed our vehicle, and we see this dunder main vehicle object at this. So this is saying that we have an object, a vehicle object. When this main, this is the name of the function or the name of the code that we were executing and where this object lives. So the file that we start our program in is just called the main. And something that you will see, did you see this? Okay, so this is dunder name equals dunder main. Yeah, this is something that it always confuses people that are new to Python. So this is just like you can define your main function like this, and then this main, like checking to see if the name equals main, all you're doing is just checking to see if that's the file that your program started executing from. And any other file that I were to import would have a different name. It would have its own name. So that's what this is. But yeah, so we have this object for a vehicle when we try to print it out. And it's showing us this. This is actually the memory address, basically, of where this vehicle is stored in the computer's memory. So this is kind of useless. We're trying to print the vehicle out, and this looks bad. So let's grab a little f string here and see if we can access some of our attributes. So these things are normally called attributes. So this program or this function here is called a class method, and in this case it happens to be a magic method or a dunder method. And this is attributes, and that's probably going to be like the object attributes. So these are going to be basically like attributes are variables, but they belong to a class object. And methods are the same thing as functions, but methods belong to a class. So function, method, same thing. Attribute, variable, same thing. You could just call these class variables, and you can call these class functions, but nobody really says that. Everyone says method. Okay, so what we want to do is we want to access some of those attributes directly. So if I put a dot after the my vehicle here, and maybe if I save, no, I'm not getting suggestions for some reason. But if I put an engine here, we can print that out. And let's just run it again. So now we're grabbing our attributes and displaying them. But you notice that we never called this init function, right? Like we did not go out of our way and we didn't call it. And I don't even know if this would work. But like we didn't do this, right? Because this is kind of what's happening. Yeah, see that's a no-go. But yeah, so the reason it's a magic method is because like we're not calling it; it's just happening, right? It's connected to when you create, when you instantiate this class object or this variable with this class object. Like it's just calling the init method. So this magic method, anytime that you do your class name and then a set of parentheses, it automatically calls this init method. And this self object refers to itself. So here, my vehicle is named my vehicle. But whenever it calls itself and jumps in here into this class, you don't have this my vehicle anymore. Because if I put my vehicle here, that's only like one copy of the variable, right? That's if I tried to create a second vehicle, and so this would actually be another one. And they're not the same. So like you wouldn't be able to put this name up here because it's different. Okay, but let's fix this print function. Like why can't we print just a vehicle? And the reason is because there's a default dunder method to print a object, but we haven't defined it. So by default, it just prints out the memory address. It prints out this this junk up here, you know. Okay. But let's make one. So instead of having to do this, and it's a huge pain to print out our vehicle, let's make a generic way to print our vehicle. So that way we don't have to do this every single time. So this one is called str. And what it is anytime that you try to convert a vehicle to a string, this method is going to get called. And whenever you try to print an object, it's going to try to convert this thing into a string, and then it will print it to the screen. So when I do print on an object, it's going to call the magic method understr. And of course, this is a class method, so this needs to be given self. And let's see. So what you want to do in here is you want to return a string value that represents the vehicle. That way, anytime something calls it, and we'll do something dumb first, and just say hello from understr. So down here, you can see we're going to print my vehicle, and it's going to call this understr method and just print hello from understr, and it's not going to make any sense. Yeah, so like this is where now we can go create a string in here that is a nice representation of our vehicle, and anytime we print a vehicle, it will display that information. So it's actually kind of cool. And so we could say something like engine. We need to make this an F string if we're going to embed some variables in line. And then we can do wheels. And now to access our attributes, we still have to use self. So that's why you pass around self. This self has access to the values of the class without, like, at all times. So you're just passing around all of the attributes of the class, all of the functions of the class. So when you have a bunch of methods for your class, you can call them from self. So everything that is contained inside of a vehicle can be accessed from self, and that's why you pass it around. So in Python, you explicitly see that it's there. I don't know why my autocomplete is not performing so hot. And wheels. Okay. This is all way better than what you got in class. Hey, I appreciate it. I really do. I'm just making this up. Okay. Yeah, so let's print out our vehicle. So I'm going to run this code again. And now you can see we have this vehicle engine in line 6. Probably should put a colon after that engine because it looks like engine in line 6. And wheels. Okay. And now there's another string method that is used a lot of times. And I just want to mention it here. And it's called repr. And I'm going to comment this out. And I just want to see what happens if we try to call it. I wonder how we access it. I don't remember how we access it. It might actually just be repr. Let me try this. This could be wrong. It's been a little while. Okay. Yeah, so we've got this repr. And a lot of times when you're logging information, you want to have a very rigorous, robust version of what this thing is. A lot of times you'll show how it was created. So it gives you two different ways to print this thing. So a lot of times what the repr will be is exactly how you would go about creating it. And in this case, we're just doing this, right? Like all we've done is made a vehicle, and this is an F string, like we're not passing it anything yet. So it would actually look like that. So now you can see we've created this repr method that it does almost the same thing as string, and a lot of times, so if we didn't have string but we have a repr, let me let's print this thing twice. So first let's print the vehicle version, and then let's print the repr. Okay. So you can see, look at this, like we got rid of our string method, and normally when we print the vehicle, it just gives us the memory address, right? We get rid of this, we'll see that they're both the same. Yeah, so now they both print the vehicle, but you saw when we overwrote the repr, it just printed the vehicle. So this print statement and printing the repr both gave us the repr. So repr is like a default value for the string. So if the string value is not defined, it defaults to the repr. And then if we have them both defined, we have like the user-friendly way to display your object. And then you have like if you were logging this information into like a system log, this repr is normally what you'll use to show like a very detailed version of what the object is. So I'm going to run this, and now we have this nice friendly print method. So when we print our vehicle, it's this. And a lot of times if you're going to log objects, you're going to use the repr version of it. And now it just shows like we have a vehicle, and it was just created using vehicle open parenthesis, close parenthesis. But our object now has a few methods. We've done a couple of magic methods, but this still doesn't really, like, kind of like what's the point? Because we only have one version of a vehicle. And let's do some bad Python before we try to do some good Python. I like that it's starting to make a bit of sense. Yeah. Got to bring the car stuff in, right? So let's make another vehicle. And it's going to be exactly the same at the moment. Oh, I didn't print vehicle 2. Okay. So we're going to print them both out, and you can see that they look like they are the same, but they're not. So there is a way, that information that we got earlier with the memory address, we can actually get access to that with the ID. And this is another built-in function, just ID, and that gives you it's a unique way to identify your objects. The easy way to think about it is the memory address on the computer, but I don't actually know if it maps directly to a real memory address, just the way Python works under the hood. So let's look at the memory address of both of these. So you can see this is our first one. Well, let's clean that up a little bit. Okay. So you can see we have our first vehicle here, which is, of course, inline 6, wheels 4. The repr method is vehicle, but then it has this address that ends in 5328. And then vehicle 2 is all the same information, but the address is totally different when you get towards the end of it. So these two vehicles are not the same thing. We've created two different instances. They're called instances. So we've created two different copies of a vehicle. We've created two different instances of a vehicle. And every time we start working up here in the class, when I call a method with vehicle 1, with the first vehicle, so let's go ahead and rename this bad boy to vehicle 1 and vehicle 2. But yeah, every time I call some sort of function with vehicle 1, the self object represents vehicle 1. And when I call any sort of method or access an attribute with vehicle 2, up here the self is going to represent vehicle 2 and make changes to it. So let's try to change this vehicle a little bit. Maybe vehicle doesn't have a inline or an inline 6. Like what is let's change the engine to vehicle 2. So here on this line right here, we create our vehicle for vehicle 2. Then anywhere after that, we can modify these. And this is what's a little bit of a bad practice. So we're modifying the class variables outside of the class, and that's kind of a no-no. But Python lets you do it. Some languages will make these private, and you're not allowed to do it outside of the class. So some languages like Java or C++, they will make these things private, and you can't access them from outside of the class. So anything outside of here, you can't modify these values if they're private. But Python, you have to really go out of your way, and we can look at that. But you can go out of your way and protect these things. But there's no such thing as an actual private variable in Python. So we can modify this thing, and we'll just put the 4-banger in it. So Now vehicle 2, and you see we made a little typo here just saying vehicle. So this is vehicle 2 is going to have the 4-banger, and we should change this without modifying vehicle 1. And in order to do that, let's print vehicle 1 one more time. Okay. I think we're done with this ID, just to get rid of the clutter. Like ID just shows you if an object is unique. If you want to compare two objects and find out if they're unique, compare the ID. But let's come down here and let's print vehicle 1 again, just to make sure that we didn't change it. Okay, so we've got our vehicle 1, inline 6, 4 wheels. We've got our vehicle 2. We put the 4-banger in it. It has 4 wheels. And then we've got vehicle 1 again, and it still has the inline 6. So you can see right here we modified engine. So we did vehicle.engine, and it changed vehicle 2, but it did not change vehicle 1. So these objects are completely separate from each other. And what's going to happen when you first start doing this is you're accidentally going to change it for vehicle. You're going to do this. You're going to call vehicle, and then, or even without this, like vehicle.engine equals 4-banger. And you're going to see some weird stuff. See, like it didn't change it, right? Like I called the vehicle object, and then I tried to set the value for engine, and it didn't work. And there's only 2 ways that this would go. Either it wouldn't work, or it would work for all of them. Because you could like, maybe you could overwrite the instance value with a class value. In fact, if I put this above here before where I create it, no, that wouldn't do it either. Yeah, let's get rid of that. But yeah, that's a common mistake. So this is just like a common mistake that people will make. They will try to access the class directly, or they'll try to create an instance of the class and then modify the engine of it. And it's not. This won't work at all. Like this is just a common error that people make, and it's like a normal problem. But yeah, we want to use the exact name of the vehicle that we created when we modify that value. And it'd be kind of cool if we had a better way to do this, because this is kind of annoying to have to. You don't really want to do this here. You don't want to create something and then modify it. Normally you want to have some way of passing these values in and then creating them right on the fly. So what I want to do is I want to pass this in here and be able to define my engine. So let's go up here. We can create, so in our dunder init method, we can actually pass in an engine. In line 7. That'd be kind of sick. So we need to get on that. And now we just set it equal to engine. And then we have wheels. And we have wheels. So these are class variables. They belong to the instance of a vehicle. Here we can get away with using the same name. Because we're referencing it using self here, we can get away with using the same name here. So this is actually kind of a good way to do this. And when we call this with nothing, so when we call it here, when we create our first vehicle, we're not passing anything in. But if you see here, we set default values. So in these variables that we passed into our dunder init method, these are default values. So now, if we don't give it anything, it will be this. But if we do pass it something, here we're going to pass it a positional argument. And you can see if we look at the way it's defined, we have this nice hinting system in VS Code. And it's actually, it's read into the future, and it's decided that, you know, engine is a string as it's supposed to be. You can see that it has like the type hint system on this here, even though I didn't bother to type that up there, which I should. But yeah, the more rigorous version of this will actually show the hints, and we'll go back and add that just kind of for funsies. But yeah, it's showing that the positional variable, the first value is engine. The second value is wheels. So I could say 6 wheels here if I wanted to, but I don't want to. With positional values and a default value on it, you don't have to provide it. So these are optional inputs. So optional input has the default value assigned to it, and we're using positional values. So this is positional, just means where it is. This is the first variable, and it gets kind of weird because up here you have the self parameter, and then the first variable is the engine equals inline 6. So now we can run this. This is going to create vehicle 2, and it's going to automatically have the 4-banger. It's not going to create it with the inline 6 and then overwrite it with the 4-banger. This is going to write it, make it a 4-banger from the very beginning. So I expect this to work. And it does. So a vehicle 1, inline 6, 4 wheels. Vehicle 2, 4-banger, 4 wheels. And then we printed out our vehicle 1 again just to make sure that there's no funny business going on. And we can actually get rid of that. There we go. So yeah, that's kind of the gist of the very beginning of object-oriented programming. And it gets a little squirrely from here. This is the good place. So this is where like this is kind of like the very intro to object-oriented programming. What the exact next step would probably be inheritance. I'm gonna take my you like the good place? I'm gonna take my dog out and take like a quick break. I don't have like a be right back in 5 minutes, but I'm gonna take my dog outside. I'll put a little timer up here, and I will continue talking about this stuff as long as there are people here. So typing engine equals inline 6 in the parameter is just setting the default value for it. Yeah, so when we're defining it up here, that is setting the default value for it. And we should be able to do something weird. So if we wanted to so what positional values give you a problem with is, let me see if I can get that back. Okay, so yeah, like if we do positional values, engine and wheels, like if we didn't want to change the engine value, but we only wanted to change the wheels value, we could parameterize it and give our car like 9 wheels. And so then we would have to name the parameter because we're skipping the first one, right? So I'm going to run this and hopefully it works. Yeah, so we have 9 wheels now. But yeah, I'm going to take a break real quick, but I will be back to continue talking about some of this stuff and any other Python things in the world. Be right back. I got to take the dog out. All right, we back. About 3 minutes into that ad, or about 3 minutes into that break, I pushed the ad button. That's the first time I've done that. Did it roll an ad? I have no idea what happened. You're back. Awesome. Welcome back. Back. I'm assuming an ad popped up. Hopefully it wasn't too obnoxious. I don't know how that whole thing works. But yeah, I think there's about 3 things that we can do from here. Let's bring up the world's greatest little note keeper here. That is bright. Oh my god, I'm sorry about your retinas. We can look at type hinting, which we should do. So we saw a little bit of it with Python just kind of doing it for us. Like you see how it says engine's a string and wheels are integers, but we didn't actually specify that information in here because Python's dynamic typed, but we do want to take it a direction. It's not going to make it static typed, but type hints are more like suggestions that tell you what to do it. So let's take a quick look at type hinting. And I don't know which order we want to do these in, but let's do some other magic methods. And then let's look at the dreaded inheritance. I can't spell. I'm a programmer. Whatever. Inheritance. We'll figure it out. There's a reason I like science and engineering, right? Oh, it is an A. I had a shot. Maybe that's why I shouldn't use Notepad. For the dreaded, yeah. Yeah, inheritance freaks people out. Alright, and I don't even do it that often. So I'll be shooting from the hip on it, and we'll see how it goes. But let's get this out of the way. Let's look at some type hinting. Okay, so we know that string, engine is a string. So all you have to do is after your variable, you put a colon, and then you put the data type before the equal sign. And what that's going to allow you to do is everywhere else that you're going to use this thing, it makes it easier and clear about what's happening. Because of the libraries that I have running in the background of Python, it actually is filling it in automatically. So this wheels being an integer, like this wouldn't happen if you're not running certain, some of these add-ons in the background. Like I have a few add-ons that really help my Python situation out. And that's Pylance, Rough, Black Formatter, MyPy, and then just the Python. Like everyone has the Python extension and Pylance, they kind of come together. But I use the Black Formatter to format my code. The MyPy is doing the type checking, and then Rough, it does something else that is awesome. I don't remember. It's very good though. What does it do? Oh, it's the linter. So it does error checking. Okay. But yeah, let's save that, and then you can see the way it like snapped and changed whenever I saved it. That's the formatter. So all it's doing is it's formatting it a certain way, so that way all of my code is consistently formatted. So that's the black formatter, and then I have it set up to automatically format whenever I push save. And then we're gonna do wheels are gonna be integers, and then down here, since this is always a string, now it knows it's a string. Now it knows this is an int. And then this is also going to be a string. This is going to be an int. And if you wanted to be like really thorough, you could put it here. And you could put it here. Probably not that necessary. But what this gives you is like a more clean code. So Python is dynamically typed, which let me see if I have a temp Python already. Oh yeah, this is a horrible sorting algorithm. I need to keep that. That's for another example later. But it's one of the worst sorting algorithms I've ever seen. I saw it online the other day, and I just had to code it up and make sure that I had a copy of it. This is just going to take a second. Okay. So you can see here, Python is dynamic typed, and what that means is you can change the typing and it doesn't enforce it. So x is being defined to be an integer here, and then x is being defined to be a string here. Or we could even go one step further and just do 9.9. and now x is being defined to be a float here, and this is no problem. Python thinks this is fine. Python loves it. But what doesn't love it is MyPy. So this incompatible types in assignment, expression has type float, variable has type int. So this is not a real error. You can see I ran my code. It ran fine, right? Look, the output is down here. I'm getting an error because I'm using very rigorous type checking with MyPy. So MyPy like really enforces the type checking automatically, but normally you're going to do it in line and you're going to label it and you're going to make things very clear. And then down here when you try to assign it, oh, this is an int. And in order for this to work properly, I would have to explicitly cast this thing to an int, or maybe it should just be 9 instead of 9.9, things like that. So now you know exactly what your code is doing. There's nothing left up to interpretation. There is probably no bug worse in Python than if you accidentally are using the wrong type. Like if you think a variable is an integer everywhere you use it, and then you get these wild results out of your program, and it turns out that somewhere in your code it got converted into a float, and then all of your math didn't really work out quite the same. This is one of the hardest bugs to catch, because there's not going to be any error or any warning. There's going to be nothing telling you what's going wrong. This is just, it's bad news. So that's why I do very strict typing with the MyPy extension. So it's something that you would install like one of the normal libraries in Python, and then Visual Studio Code. Yeah. Yeah, 81. Yeah, it's the worst. Like if you've been there, then you know, because it's so hard to find. You have to it's not going to show up. Like there's not going to be an indicator and what's going wrong. You have to go find what's going wrong. So, and then self is just kind of always going to be a vehicle. You don't really have to define that. And then the other thing that we need to do, or should do, is define the return type. So this is going to return none. The dunder_str methods are going to return strings. And dunder_repr is also going to return a string. And that pretty much does it for putting in our... It's more important. The dunder methods kind of, like, these things already... Like, this is always going to return none. This is always going to return a string. This is always going to return a string. This is kind of, like, typing it out here, kind of unnecessary, not going to lie. I don't even know if you would even want to type it out on the dunder methods, because they're already defined. But when you make your own methods and your own classes, that's where, like, this main should have a none. Like, main is going to output none. See, there's no return value in here. Okay. Excuse me. So that's type hinting. It gets a little bit deeper than that. There is a import. That is bad auto formatting. So there's a library called typing, and you can import. One of the main ones is optional, and you'll see it in old versions of code. You can't like use the lowercase list. So in Python, list is lowercase, but you can't use that in your type hints before Python 3.10. But Python 3.10 fixed a lot of this stuff, and you don't have to use this anymore, so I won't be using the typing most of the time. But yeah, there's a lot of options in there with the typing, but I'll be using the Python 3.10 and beyond methods if those were to come up. But yeah, that's typing. Let's take a look at some of the other magic methods, and I actually just want to look at that because that's kind of a cool thing to see in the documentation. There's a whole bunch of them. Too many of them. Let's just go find a useful, like a normal one. We're on the wrong page. Oh, did I put an extra? Is that 3? Oh, there's a space there. There we go. Okay, so we can look at some of these things. So emulating numeric types. So these things map to the symbols. So whenever you add two integers together, the integer class, like an integer in Python is an object. And somewhere in there, what just happened? Okay, somewhere on your integer object, there's an add method, and this thing maps to the plus symbol. Subtraction maps to the minus symbol. Mul is the asterisk symbol. Matrix multiplication, I'm not sure what symbol this thing multiplies to or maps to. Mod is the percent symbol. So whenever you try to find out the remainder for integer division, it's calling this mod method. Pow is defined by 2 asterisks. Left shift would be less than less than. This is for doing bit shifts. Right shift would be greater than greater than. And is the word. Actually, these might be the bitwise operations. So those could be and, or, and XOR. Most likely. So we could look at those. The XOR. Is it defined in here somewhere? Yeah, right here. So and, XOR, and OR. So these are the bitwise operations. Yeah, you wouldn't normally see them. We can look at a quick example of it. It doesn't take too long. But let's grab our integer value of 4. And this thing, if you look at the binary for it, it's going to be 1, 0, 0. So this bit represents 1. This bit represents the 2's place, and this bit represents the 4's place. So this is going to be, and I'm just going to put an extra 0 in here, so that way it's a 4-bit number. But it's going to be like 0, 1, 0, 0. That's the binary for a 4. And then if we did a 7, that's going to be 0b, and that's going to be 4 plus 2 plus 1 is, so 1 plus 2 is 3 plus 4 is 7. So this is the binary of a 7. And then, how do we do? So we want to print out the AND symbol for this. So X, oh boy, I am forgetting how to type, and Y, right? So this is going to perform a bitwise AND operation, which just sounds crazy. So what it's going to do is it's going to compare this 1 to this 0 and AND them together. And since we have a 1 and a 0, 1 is kind of like true, 0 is kind of like false. So this is going to be a 0. And this 1 is going to be ANDed with this 0, and it's going to be a 0. This 1 is going to be ANDed with this 1, and we're going to have a 1. So the output value of this thing, let's actually call it Z. I'm expecting, I could be totally wrong here because I'm just, we're doing this on the fly here, but I expect Z to be equal to this. So let's turn this thing into a Z, right? So Z is going to equal the bitwise AND operation between X and Y. And this, of course, is also equal to 4, as it would be, right? So now we have this 4 here. So you can see we output the value 4, and that's what Z is. So these are bitwise and, or, and exclusive OR operations. The exclusive OR means only one of them is true. So if we did an XOR, there's not really a reason to know this. So this is going to be the last one. And there's a reason, I went to school for electrical engineering. It's the reason I know this stuff. And it comes up in, if you write a buffer for data that's going to be sent over a comm link or something like that, you're going to be working with binary versions of the data. So if you work with raw binary data, these are actually useful. Yeah, it's exactly like, what's funny is Minecraft is straight up engineering. So you can build basically transistors in there and and OR gates, and you can build entire who's the guy? There was a guy who built an Atari computer inside of Minecraft, and it refreshed at something like 1 hertz, something, or it was might have been worse than 1 hertz. It might have been worse than 1 frame per second. It might have been like 10 frames per second or something awful like that. Let's see. Okay, so we want to do the XOR. And that's this. Cannot type. But before we do that, we want to guess what it is, right? So an exclusive OR means only one of them is up. It's like an OR operation, but whenever you have 1, 1, it'll be false. Because if you ORed these things together, you would get 7, right? Because it would just be 1, 1, 1. So it would just be another 7. So we're not going to do the bitwise OR. But the exclusive OR is going to be 1, because there's 1 high. There's 1 high here, and then these two are both high, so through an exclusive OR, that's a 0. I'm expecting this to be 3. Like this. So we should see a 3. Yeah, and then we have 3 here, so we've confirmed the universe is not broken. Everything is working as it should. Yeah, people, I actually, like, when I play video games, like, well, I don't play Minecraft, but there's a reason. Like, I don't play Minecraft because it feels like work. I tried playing Polybridge, and you get to a certain point in Polybridge, and you start doing engineering, and I'm like, I should probably just go get an engineering job. So, I get, like, it's really fun, and the stuff is enjoyable, but, like I went to school for engineering, so when I get too far into those games, and it starts to feel like work, I'm like I should be getting paid to build this bridge. like get out of here. But yeah, that's what those operations are. It's not really anything too crazy. But let's try to build one of these things for a car. There's no reason why, but the thing is, so you can overwrite these and you can define them for a car. So let's see what happens if we add 2 cars together. So let's build an operation that adds 2 cars together, because that's a ridiculous thing to do. And the car that you get out of that deal would actually be kind of sick. So let's look at this. So whenever we define add, you pass it itself, and then you pass it another version of that same object or some other type of object. So let's def. We're going to add 2 cars together. We're going to add ourself. And then we're going to add vehicle. Or vehicle 2. Or just maybe other vehicle. Let's just call it other. So this is self, this is the other. And we want this thing to return a value, right? We want to return a vehicle. So if we go down here and we look at Python, and we just do 5 plus 4, like let's print it out. 5 plus 4. This operation returns a value. So we took the 5, we added a 4 to it, and we actually returned the value. And then, in this case, it's probably a new one, but okay. So what we're going to do here is we're going to return vehicle. And we have some problems here. So undefined name, other, name type, vehicle. So this is a problem. And what this is, so this is called a circular import. In Python, being the wonderful language it is, it has this little problem. So we are inside the vehicle method, and we're trying to use vehicles inside the vehicle method. And that's kind of a problem for where we're doing it here. So what we need to do is, so there's 2 ways to fix this. Whenever you're doing type hinting, this is a problem because the, oh wait. First of all, this one is backwards. Other, I'm used to languages where you define the type first. Yeah, so now we have the same problem in both spots, right? This is where you'd find a way to use the execute function. Oh, dude, stop using the execute function. You're going to take down the system. The world is built on not using the execute system. Yeah, see, this formatter thing, it has a bit of a problem. So you can see that this is yelling at me because it doesn't want to use vehicle in type hinting inside of the vehicle class. So the old fix for it is you just put strings around it. And man, that is ugly. Look at this. So now I have like this type hint that is in string format and the error goes away. Python is a grotesque and hideous language. I don't know why people choose to use this. The other thing that you can do is from future. You thought the dunder methods were bad. Yeah, it's actually dunder future. Import annotations. So the future library is full of all of these new features that are coming to Python, but they're just not part of the main Python standard library yet. So they've been trying to get annotations in Python forever. They just can't figure out quite how to perfect it and get it in. I'm sure I'm butchering this, but this has been here for a long time, and it's about time for them to roll this. I thought Python 10 was when they were going to roll this in with the main Python standard library, and then this error would go away. But yeah, what you're supposed to do, those strings are hideous because then your type hinting has strings mixed in with it, and it's just an awful thing to read. So yeah, we import annotations from future, and then we can do type hinting with these circular imports. Because otherwise, you're trying to like import a vehicle here inside of the vehicle function. That's called a circular import, and that's the problem. But our add method is going to return a vehicle, and I just saw something that we never went back and fixed. We didn't fix our repr method. Now that we actually have these, so we have this, usually the repr method is going to show you exactly how the vehicle was made. So we want our vehicle repr to show us a better version of it. So let's fix our repr and give it some values here. So this is going to say something like engine equals self.engine. And I'll show you the actual output of this. And then, because it's not going to be inline 6, and then it's going to be wheels equals self.wheels. And this will make sense when we get to the output of it. So let's run this thing and print. Make sure we're still printing the reprs, which we are. And this thing is defined, but it's not well defined. So we'll come back and fix that in a little bit. We have to exit our Python interpreter that we have down here. Let's run this bad boy and see if we can get there. Did I break it? That's not a problem. We don't have a real problem. I tried to run it with the Python interpreter open at the bottom, and it doesn't run in debug mode whenever you have that interpreter open in the main debug window. You're supposed to open up a new terminal and then open up the Python interpreter. Okay, so now you can see our repr method. See this vehicle engine equals inline 6, wheels equals 4. That almost looks right, except for this string should have the strings, the quotes around it, right? So we're inside of a double quote string, so we can use a single quote string and get away with it. So what the repr is supposed to be is you're supposed to be able to, like, one of the normal things you'll do with the repr is you want to be able to grab this, copy and paste it, and just put this in your code, and now look, it works. Like this is the way that I would create the vehicle with the inline 6 with 9 wheels, right? Like this thing is good to go. And we still have 9 wheels for some reason because we never went back and fixed it. Yeah, wheels 9. Let's do wheels 6. Like 9 is just such a ridiculous number of wheels to have. Okay, but we're about to make a new vehicle. This is about to get stupid. So we've got to go define our add method, and then we're going to make ourselves a third vehicle. So right now, add just returns a default vehicle, which is stupid because that doesn't make any sense. So what we want to do is we actually want to define this to be self.engine plus other.engine self.wheels. And maybe we don't want to add the engines, but I think this new car, when you add 2 cars together, right, you have twice as many engines and twice as many wheels. Like, we're already doing something stupid. Like, let's just go all the way. we're demonstrating that you can write an add function for your custom. You can create add function for your custom objects, just like if you were going to add two integers together or something like that. So here, like now, like our custom add function for our object is going to add the two engines together, and these are strings, and the add function is defined for strings. But let's make it make sense here. So we'll say that it has and because it has multiple engines, right? So we're gonna add one engine and the other engine, and then these are integers. So the number of wheels is an integer, and we can just straight up add those together. So now we're gonna create this new vehicle. When we do our add function, we're gonna create a new vehicle, which is going to initialize that new vehicle with these values that we pass in, and the values we're passing in is a combination of values from the two vehicles that we're going to add together. This is like absolutely just mind-blowing stuff here, right? Let's stop. It's not that cool. Okay, so let's make our third vehicle, and now vehicle 3, we're not going to create a new vehicle here because we already have two other vehicles. We're going to take vehicle 2 and we're going to add it to vehicle 1, but that is kind of a stupid order. I mean, it doesn't really matter. There we go. Vichili, I like it. I'm still, I'm just butchering this thing. Okay, so now we have vehicle 3. Let's print vehicle 3, and let's print the repr for vehicle 3. So what we've done here is we've created this add function for vehicle 3, or for vehicle, and now if we run it, and I'm not terrible, let's see what this is. What do we do? Oh, we used wheel instead of wheels. All right, let's try again. Okay, so now we have 3 vehicles here. This little Y character is creeping me out. Oh, it's coming from here, new.py. We're like 1 character shy. Get out of here. And then we'll put a new line here. Hold on. It's been bugging me for too long. I can't take it anymore. Okay. Okay. So we have vehicle 1, inline 6, 4 wheels. We got the repr that shows us how we can create this exact vehicle. We got vehicle 2, inline 6. What happened to our 4-banger? This will not do. Oh, we got rid of it because we set the wheels. So we can actually use a combination here. We can do this positional argument, and then we can also give it the parameterized argument as well, and it'll figure it out. But because we're doing it this way, we don't actually need to say wheel 6. We can just say 4-banger, comma 6. And now that both positional arguments will work, run it again. There we go. First vehicle, inline 6, 4 wheels. Second vehicle, 4-banger, 6 wheels. Kind of stupid. The car with 4 cylinders has 6 wheels, and the car with 6 cylinders has 4 wheels. Doesn't really add up, you know what I'm saying? We're going to combine these things and see if we can get 10 and 10. So now we got the inline 6 and the 4-banger combined together with 10 wheels. It's a monster. We have done it. And then if you wanted to put this in code and create like this, this shows you exactly how you could go about creating that object directly without doing the addition or whatever. So this is the repr. This is the dunder string output. This is the repr output. Okay. There we go. Okay, so we've done it. We have overloaded a magic method, and you can do this for every symbol in, like every built-in thing in Python. And if you ever want to know, like if you see something, like if you, you would drive that. Yeah, I would drive that too. Actually, I've driven something with at least 10 wheels. It was, I gotta find it. Hold on. Story time. Let's see. Flight line. Line palette. Truck. I don't even know how many wheels it had. I'm going to say 16. Let's just find out. Can I even find this thing? Rollerized palette. Truck. Let's find out. Oh, it does. It is hard to find it on the internet. I can't believe this. Oh, cargo. Yeah, so I'm getting pallet jacks. I'm not gonna Google in public here, but oh yeah, it's like this bad boy. Yeah, yeah. So this thing, what is that? That's at least 10 per side. That's got 20 wheels. So I've driven one of these things. And you want to talk about turning radius. You should see the dumb stuff that people do in that thing. Yeah, they get that thing on the flight line screaming, but it corners like a dream. So yeah, the palletized cargo truck. It's been about 20 years. It's been a minute since I drove one, but yeah, those things are cool. Um, let's see. Okay, yeah. So the Dunder methods. Get the chat back. So baby. Yeah, it's fun to drive. It really is. We had somebody wedge a pallet on it like diagonal. I don't know what it'd be like. I don't know, putting like a square into a round slot and then turning it sideways or something. Like the pallet on the pallet truck got twisted because they like hit it or something. It was a nightmare. I don't even know how they got it free. Like, I think our team went home for the day and then somebody else fixed it. But yeah, those things, they were a good time. Um, let's see. So yeah, any one of these Dunder methods. Yeah, what I was about to show off here. So you can define any of these Dunder methods for your class objects and create your own methods. Like we could raise a car to a power. We could make a division modulus. Like none of these things make sense. You could divide a car in two. Like I don't know what that would look like, but you could define it for divide. But what we can do is let's go over here and open up a new Python interpreter. And I'll just show you. So if we have some sort of int, and then there's this command called dir. I like to think of it as directory. I don't really remember what it stands for. I could probably find out right here, though. It's called an argument. It returns the name of things inside the current scope. It doesn't actually say. It's just dir. Okay, so we're going to call dir on x. And we get back all this stuff. What it does, it shows you all of the Dunder methods and all of the class methods that are defined for this object. So x is an integer. So we could just as easily do this for int. Right? So if we do dir on just int generically, so you can see we can take the absolute value. So Python has a built-in function called absolute value, ABS. It's built in. So if you wanted to define an absolute value for a car, you could define a Dunder ABS method in here. This is the add. This is the bitwise and that we showed, bool. So if you wrap it in bool, or if you convert it to a boolean, like any time that your object was going to be converted to a bool, this is what would be called. Ceiling is going to round up. Class, you wouldn't really do that, I don't think. I'd have to go look at how you do. So these are these methods are for, these are not really. So they're probably better called instance methods. I think so. There's class methods that only work on the object and don't access the instance. So it's a bit of a, that's not what this is, but you put a decorator on it. Decorator is probably a thing for another day. But we could overwrite the DRI method. But yeah, so if you're ever wondering, you're trying to like, oh, well, how do I define greater than? Here's GT. How do I define less than? There's less than. Less than or equal is over here. This is how, if we said vehicle equals vehicle, like this is something that we should probably have, like are two vehicles equal to each other? So we'll do one more Dunder method just for fun, and I think the equal one is a good fit. But yeah, if you're looking for what kind of methods you can add to your class and you're trying to overwrite the symbols, you can just look at these. Like there's the exclusive OR we looked at. There's all these Dunder methods. They all do something special and unique, and you can overwrite them for your class as you see fit. So let's do equals, and of course equal is going to return a Boolean value. And it's going to have itself, and then it's going to have other, and it's going to have another vehicle. And now, how would we check if a vehicle is equal to each other? We would probably check two things. And the way a vehicle is currently defined, it would be something like self.engine equals other.engine. So you can see that engine is a string, and we can define equals equals for a string method, and then we can do the same thing for the number of wheels. The wheels. And now, are we in a pickle here? Incompatible with supertype object. Supertype defines argument type as an object. Is recommended for dunder equal to work with arbitrary objects. So they're recommending that we compare it to any type of object instead of just a vehicle. I wonder if they... This is kind of silly because, yeah, like, we're accessing these like other cars. I don't think that's actually... I don't think that's a real problem, but we'll get rid of the vehicle definition there just to make it be happy here. But now we can do things like check if any of the vehicles are equal to each other. And we'll see if this works first try. I mean, who knows? Let's make a fourth one. And that's just going to be another default vehicle because I want to have another one that is not the exact same. So I don't want number one to be the exact same object as what we compare it to. There's no, just so that we know we're comparing it to something else. Okay, so we can see that vehicle 1 is not equal to vehicle 2. They have different number of wheels and different engines, right? And vehicle 1 is not equal to vehicle 3. Vehicle 3 is a 10-wheeled, 10-cylinder having monster of a car. And vehicle 1 is equal to vehicle 4 because they both have, what's the defaults? They both have an inline 6 and they both have 4 wheels. So now we have created the logic for this, and where this really matters is if you tried to sort two items. Sorted return a value? Yeah, sorted returns a value. Oh, see, they already know. They already know what I want to do here. So if we wanted to sort our items, equals equals is not really what we need. We need a less than defined. So normally whenever you're sorting things, they tend to use the less than operator. And it might actually say here. But yeah, so we're going to call this sorted thing and see what happens. It's probably not going to work. Yeah, so now, see, we have this error type X less than symbol not supported between instances of vehicle. We never defined less than, right? So the only way it gets a little weird when you try to compare cars. And I think we decided that the less than was LT. And let's just compare wheels. We could compare the strings, but for the engines, it's going to get a little weird. So we're just going to compare the wheels. So whichever car has the most wheels is the bigger car. Let's try running this again now that we've defined less than. And it is working here, but it's looking a little ugly. Let's print this sorted value out a little bit better. Let's just call this sorted B. Something wonky happening here. Okay. So now you can see that we have printed the word vehicle 4 without ever actually printing it. Okay, so we have sorted our vehicles, and they're printed out right here. All right. Vehicle 3, the repper. There's the repper for vehicle 3. So we've sorted them. We have inline 6 with 4 wheels, 6 wheels, 10 wheels. So this is vehicle 1 or 4. This is vehicle 1 or 4 because they both have inline 6 and 4 wheels. And then vehicle 2 had 6 wheels. So you can see like vehicle 2 was in the 2nd position, but now that we've sorted it, it's in the 3rd position in our list. So now that we have defined the less than symbol, we can put our vehicles into a list and we can sort them. So we've really started to beat these dunder methods to great effect. But yeah, less than is one of the super important ones. String and repper are very important. Any object that you define and you're going to be using regularly should have a string and a repper method, because the string just lets you debug it because you can just start printing your thing out. And repper is just a better representation of it. Formally, it should probably be there. And dunder init just comes, everyone knows dunder init if you've done object-oriented programming in here. How are we feeling about that? Looks good? Still confusing? What do we think? Bool. Get out of here, Bool. Okay. Let us continue. Where's my notepad? All right. It's not as huge as it used to be. That's good. Okay. So we looked at type hinting. It does get a little weird. We showed that we have to import annotations if we're going to be doing these circular imports. We also saw that the equal method doesn't want you to use type hinting on other because it wants to be able to compare vehicle to other objects, even though down here it would break because we're doing this other.engine method, which if this other thing is not a vehicle, it's going to break anyway. I'm not sure what's up with that. But now it's time to look at the dreaded inheritance, which is everyone's least favorite thing. But the car example lends itself, or the vehicle example lends itself to this perfectly. And there's a reason we called it vehicle instead of calling it a car. And that's because now we can define other more specific vehicles. So vehicle is very generic. Anything with engine and wheels is going to be a vehicle, right? But what we want is we want to define a car. And a car is a vehicle. So we don't need to start from scratch. If we want to define a car, and we need to get rid of some of this stuff. Let's get rid of this. All right, let's run it one last time, and we'll say goodbye to it, and then we're gonna make our car. So this is now going into the vehicle playground. Oh. All right, it all works. So we've moved that into this vehicle playground function, and we're not gonna work with it anymore. We'll go back in here into the main. So we can actually we can get rid of this. We're not calling that function now. And now our program doesn't do anything anymore. And we can get started fresh with a car. This is actually just kind of taking up space. But I want it to be there for later. Let's put it down here at the end. I wonder what happens if we define... Yeah, this is fine, because we're not even calling it. Okay, so that's just out of the way. Wow. That is not what I was trying to do. Okay, so if I were to take this and turn it into a lesson, at least I have this. I don't know if I'll go record the lesson. But, okay, so now let's go to our vehicle, and we're going to build a car. And it doesn't get any easier than class car. So we've defined a car. We're creating a new object. Doing a little object-oriented programming. And this is going to inherit from vehicle. So a car is a vehicle, right? And if we just do pass, We ought to be able to start doing this, but we'll see. Yeah, there it is. So we have vehicle, engine, inline 6. This is our car 1. Let's run it again a little more clear. Car 1, vehicle, inline 6, wheels 4. So all we've done is we've created a car, we've inherited vehicle. So a car has everything that a vehicle has. So we can actually compare cars together, we can make cars, and we can sort cars, and cars do everything that vehicles do, right? So let's start to customize cars, because cars do a little bit more than your generic vehicle does. Now, the way this is formatting, sorry, the auto formatting on my Python formatter is just like, it goes insane. So what we usually want to do is we want to make sure that we perform everything in the previous initialization method. So this dunder init method is going to overwrite this vehicle one. And if we just overwrite it, it's not going to work anymore, right? So, and it may actually perform the old one by default. But I'm just going to put a pass right here, just saying we're not going to do anything. And we're going to run this code, and now you can see it's breaking. Car does not have an engine, right? But a vehicle has an engine. It happens right here. But inside of our car, we overwrote the initialization function, and we didn't do anything. So this is already a huge problem. So everything that the car does to initialize, we need to do with the old version, and that's where we do our super. And then we want to pass it these things. And this is where we can change the default values for a car if we want to. So our dunder init method for a car should at least have these things. Or we could leave them the same. But now we're going to pass them in here. So we're passing this thing wheels, and we're passing this thing engine. And now this is going to create a car which is based on a vehicle. We have a custom initialization feature function for a car, because car is going to have some other stuff. Car is going to have more than an engine and wheels. Car is going to have doors. And our default car is going to have 2 doors. Now we have self.doors equals doors, right? So now we've created all of the things that normally go on our vehicle right here. We've called the old initialization method. It is possible to get rid of this. If you didn't want to do all of this stuff, you can completely get rid of it and have a custom initialization function for your car, but it better not break the rest of this stuff, or else you have to rewrite all this for your car anyway, and then why are you even inheriting anything? So, don't force inheritance. If you find yourself doing all this weird janky stuff to make inheritance work, maybe it's time to just create a different object. But inheritance in this case makes a lot of sense, because a car is a vehicle, a car has an engine, a car has wheels, and now a car has doors where a vehicle may or may not have doors. A motorcycle doesn't have doors. A boat is a vehicle. A boat may or may not have doors. Maybe they have little doors or something to get to the deck or something. But yeah, but now our car has doors. And now we're going to try to print our stuff here. And we see car 1, vehicle, engine, inline 6, wheels 4, and a bunch of our other stuff isn't going to work. And we have to continue to update it if we want it to continue to improve. So it doesn't get you all the way there, right? So we've inherited this car. This car does a lot of things, but maybe we want to sort by the number of doors and the number of wheels. Maybe we want to sort by wheels plus doors, or maybe we just want to sort by the number of doors. Something else it could have, you could have passengers. We didn't really think about the number of passengers on a vehicle, but that could be defined here, and then it would inherit into everything. So if I wanted to go back and add passengers to every type of vehicle, I can go back up here and add it to vehicle, and that's automatically going to propagate into our car here. So you end up in these situations where it all just kind of works. What else do I want to say about inheritance? I mean, that's not the whole story, but that really just gets you there. Because the other thing that you can do is you can do other objects as well. Like motorcycle. And that's going to be based off of a vehicle. And that's going to have its own dunder init method. So everything has a dunder init method, even if you don't change. Usually you will define this anyway. A lot of times it'll just look like this. I'm just gonna see here. Okay. Oh, let me check chat here. Did I fix it? No. Oh, there it is. Had my C in the wrong spot. Okay, so now we have a motorcycle, which is exactly like a vehicle, except wheels equals 2, something like that. So now when we initialize our vehicle, we can pass it wheels equals 2. But we'll continue playing with that in a moment. Let me check chat here. Been staring at the screen for a bit. Built-in Python documentation right here. Yeah, that's the DRI method. Hey, I push out truck drivers, so better be a Python coder. I don't know, man. ChatGPT is going to be pushing out coders, too. Welcome, Salik, by the way. Or CJ. Thanks. Nice. 81, you have learned. Mr. Python, yes. What the hell is a super? Yeah, that's a good question. A good question is, what the hell is a super? So a super is the thing that we're inheriting from. So this super represents this object, basically. So this super is our instance of the vehicle. Because when we call this thing, like notice that we're not passing itself, but it still worked, right? So we didn't have to pass itself. So super is an instance of a vehicle, and it's just a little wonky. It gets worse, though, if you do multi-inheritance, and we're not going to talk about multi-inheritance because you normally don't want to do it, and everything gets weird. But you can inherit from two things. Like if we wanted a motorcycle to be part vehicle, part car, this wouldn't really make sense. I mean, a car is a vehicle, so it's not getting that much of a stretch. But you can inherit from two completely different objects, and it can actually work. And that's called multi-inheritance. And then when you call your super, you actually have two different supers to deal with, and you have to give it the name of which object you're calling. So super is just the way to reference the thing that you've inherited. And it only becomes super important. Super. But just pretend like that didn't happen. But it only becomes really important when you try to do multi-inheritance. But you will probably never see me talk about multi-inheritance because it's not that it's useless. It's just that there's probably a better way. Yeah, the only thing that I would want to see multi-inheritance on would be something like a Pydantic base model. So Pydantic is like an extra upgrade to the typing system. I'm sure I'm not doing it justice, but Pydantic is amazing. It's part of the Fast API backend software. And you build your objects off of a base model, and then it enforces all of your types. So all of the types that you define in your objects, like these types, are then enforced whenever you create things during runtime. So all of this type hinting that we're doing, these are just nice to haves. Like Python is like, please do this, please don't violate this. But when you run the code, it doesn't matter. Python is still dynamically typed. You can do all sorts of dumb stuff to get yourself in trouble. When you do Pydantic, you can build your models based on the Pydantic base model, and then if you violate your type system, it actually throws an error during runtime, and it will straight up break your code, just like you would expect to happen in something like C++ or Java. So Pydantic is great, and if you ever do fast API, it's what makes your backend like rock solid. Like you can program your backend to actually perform properly because it has all this type enforcing stuff in it. And you don't have to worry about people passing all sorts of weird jank to your back-end system that could completely mess it up. So, yeah, it's a little sidetrack, but to like really strengthen the type system, look at Pydantic. I wish I was better at it. Is this stream going to get uploaded and saved somehow? Yeah, I think it's saving by default. I will probably chop off the beginning where I do the Rocket League part because it's not really like that's fun, but it's not educational or helpful. So. Yeah, I'll cut off the Rocket League part, and then when we start talking real Python, that's where the replay will start. If for some reason you like really got to see that beginning Python stuff, probably not gonna like we can go over Rocket League again. Like it's just so it's kind of overwhelming. So Python programming environment, not for beginners. Yeah, cut out the 5-minute break. Yeah, good reminder. Appreciate it. Been going for 2 hours. Should probably actually wrap. Let's see. Just taking a little note here. Okay, so let's finish the motorcycle. We're not going to do very much with the motorcycle unless we find it. I don't know anything about motorcycles. Like, does it have a kickstand? So we could do something. I mean, that's kind of silly. I mean, like it has 0 doors, but and this could be a bool, and it probably has one, right? Unless it's like a bicycle or something. And then here, so if you never want to change the engine, but we do, so, but every motorcycle is going to have 2 wheels, right? So we don't need an input for wheels anymore, but we do need an input for engine. And it's still going to be a string. What is a motorcycle engine? I don't know. 2-stroke? What is that? That's like a dirt bike, right? Is that a dirt bike engine? It's 2-stroke. They have to mix the oil with that? All right, let's do, okay, like a 150 or something like that. Or, yeah, isn't it like 150 cc? Is that a motorcycle engine? That sounds like a real thing. Yeah, I'm not. Yeah, it's all good. Okay, so yeah, we're gonna say 150 cc and pretend like that's a thing. Did it just? Oh, look at that! It supered me. It said you're gonna do string like so in Python. Single quotes and double quotes are good to go either way. My formatter says no, you're using double quotes. So you can see like if you're just learning Python, that's kind of a warning. This black formatter, this type checker, and this runtime error thing, these might actually get in your way and create more problems and make you lose your mind. So like you may not want those in your environment. But yeah, back to the motorcycle. So yeah, it's pretty funny though. I actually like the double quotes because I come from C++ land. Single quotes represent one character. In C and C++, you can't do strings with single quotes. You only do single characters with it. So I actually kind of like this. But yeah, so we're going to have an engine, and then we're going to have a kickstand value. And it's going to be true. Because I imagine that every real motorcycle probably has a kickstand. And then let's go ahead and make a bike. And we're going to have a bike. And then we're going to print it. And we're going to see that it gets a little weird here, right? So the bike still has an inline 6 and the wheels are 2, so we did not fix our engine. And now we don't have to do the named. Now that we're doing these, we're passing these with the correct position. We don't have to do the parameterized wheels anymore. So we can just put them in order. Now our bike has a engine and wheels, but I don't see a kickstand anywhere. So I'm going to try this, and we're going to try to work with the inherited version of our string method. And we'll just see what happens, you know. That's what I like to see what happens. So what we're going to do is we're going to try to call the super. And do that. And then we're going to add this. And it's probably not going to work. And if this doesn't work, then we'll try something else. But we can actually we can get a little squirrely here. I mean, this is a Boolean, so with this kickstand being true or false, it's going to look kind of silly either way. So this actually works. So you can see we called the inherited string method, and then we just appended more string to it, right? So this is very helpful. Now the repr is going to be awful. The repr is going to be broken. So we would actually have to go fix the method, which I'm not going to do right now. Fix the repr method because it's going to be terrible cycle. Yeah, so this repr method for the motorcycle is saying you can create it using vehicle engine equals 150cc, wheels equals 2, but you can't create a motorcycle with vehicle. That doesn't work. So we have to actually redefine the repr from scratch. Because to modify the string would just be kind of a waste of time. But yeah, this actually worked by calling the inherited dunder string method and then appending the kickstand to it. And then we have this kickstand true, but yeah, that's fine. But it could show the flag. We could take this opportunity to introduce a ternary operator and say something like it has a kickstand and a bunch of exclamation marks. And we only want to do that if, since this thing has a Boolean value anyway, so we only want to do that if it has a kickstand, else nothing. So it doesn't have anything. So we don't need to do anything. We don't need to change it. Or we could say something like, oh, no kickstand. And do a frowny face. Right? All right. So it's going to reformat that a little bit. So vehicle, engine 150cc, wheels 2, period. It has a kickstand. Right? That's awesome. So this auto formatting, my line got too long, and it just went ahead and wrapped this thing in parentheses. So parentheses allows you to do multiple lines. And it's kind of like defining a tuple with one item, but it's not. It's just a set of parentheses because a tuple with one item would have a comma here. But yeah, you can do multi-line stuff with a single set of parentheses. But now we need to let's find out this false value here. And this ternary operator has become multiple lines, and it just looks like absolute trash. I feel bad for everything that has happened here. But I do want to see the other version of it. So, bike, period. It didn't print the other thing, and it just says, oh, no kickstand. So our I know what happened here. But this ternary operator, so if it has a kickstand, it does all of this. It treats this is one string. So these operations happened first. Where what we really want is we want an extra set of parentheses like around this thing. And now that we're stretched out onto multiple lines, I actually don't know if this is going to work. Yeah, so I think the formatter's not going to let me do it. let's see, vehicle, 150cc, wheels 2 on, no kickstand. Yeah, okay, so this extra set of parentheses, then they broke out the multi-line things, but this is actually ugly. So this thing right here is called a ternary operator, and it's this value if this statement is true. Else, it's this. And this is a pretty ugly, the way this is embedded in something else, let's just call it what it is. This is like Python code. Don't use operator like this. Is it TUR? Let's see. TER. Gotta learn how to spell. Don't use ternary operator like this. This is disgusting. So yeah, usually like if you just do it in line with a simple return statement, it works fine. But because we have this super call and we're adding it, and then the line got so long that we had to do a set of parentheses, this is a no-go. This is not clear. This is really confusing. So this should be done in a better way. But I am going to wrap it up right there. I think we've done a lot. So we started out, we made our vehicle class from the ground up. We talked about all the magic methods like the string and repr that everyone wants. Then we talked about overloading some operators. We added the plus symbol, the equals sign for comparison. We included a less than symbol so that we could sort these things. And what's kind of cool with this inheritance, oh, we got to do one more thing. I'm trying to wrap, but I got to do one more thing. We can actually compare bikes and cars. So, and it should just work. So car 1 less than bike. Is it? I don't know. So it's false. So the car is not less than bike because we're comparing the wheels. So car has 4 wheels, so this is 4 less than bike's number of wheels 2. It's false. But so we could put vehicles, bikes, and cars all into a list, and we can sort them by the number of wheels because the less than function is defined in the vehicle, which is inherited by the car, which is inherited by the motorcycle, and it just works. So you can start to see how Python does all sorts of awesome magic stuff for you when you use inheritance properly. So yeah, inheritance is your friend. It's nothing to be scared of. It's just don't try to force it where it doesn't belong. And a thing like vehicles, motorcycles, and cars is a very easy to wrap your brain around example of inheritance. What is not easy to wrap your brain around probably is the Connect 4 game I wrote had inheritance for game states and the AI. So the AI was like an object in here that you could inherit and like have different. It was nasty. I don't even know where it is, but yeah, it was some like weird object-oriented stuff that just doesn't make sense. But let me visit chat one more time. Same thing. Not good with car parts. And you usually use double quotes for strings. Yeah, I feel like a lot of people use single quotes and strings, but since the black formatter is forcing me to use double quotes, it's got to be. This has to be more important. So I follow the creator of Fast API. So like Fast API is my favorite library in Python pretty much. You'll probably hear me talk about it a lot. I don't actually program in it very much, but the creator of Fast API, this is his stack for development. He said like this like these things like the rough, black formatter, and MyPy together, these 3 things are like what he does in his development environment to help him keep everything straight while he's developing Fast API. And since Fast API is like, it's amazing. The way it's written, it just works great. So I'm willing to adopt whatever it is that he's doing. So this is my development environment, like strictly because of what he does. Thank you. Stream's amazing. Learned a lot. Yes, it's been a pleasure. Do hit that like and subscribe button, Mr. Python. I appreciate it. Glad it was helpful. Yeah, this has been a good review for me, and it was nice to dig back into object-oriented programming. It's been a hot minute. I don't get to do this every day. So, yeah, keep an eye out for the streams. I do not have a streaming schedule yet, and for free, right? I know. Watch those ads. But yeah, I don't have a streaming schedule yet, but I am probably going to run these office hours, and we'll probably just talk Python or whatever stuff whenever. Doubt you'll be applying the things we learned because summer break. Now you need a so what you need is a personal project. Like you need a hobby that involves the thing, and you're doing Java next year. I wish I knew Java, but oh man, it's so ugly. I mean, like I know C++, which is also kind of ugly in the same way, but Java is just different for me. But I'm doing data engineering right now, and a lot of stuff is in Java because a lot of the like the Apache ecosystem is built on Java and Scala, and Scala is kind of like a Java type language that does functional programming. And I should probably be learning Java and Scala, but right now I just can't bring myself to do it. I'm gonna focus on Python, and I'm gonna focus on SQL in the near future. So maybe on one of these streams, I'll fire up a fast API backend, and we'll connect it to a SQL database or something like that. Like that would actually be probably a pretty legit time to grind through, and it would be doable. Yeah, Java does look scary, man. Every time I look at Java code, I just feel like it looks really ugly. like, and I like C++, so that says a lot. It's crazy. All right, last second. I am out. Thank you for watching. End of stream. I'm gonna roll an ad. See ya.